Alrighty. So we have our foldable. You took the foldable, and if you haven't done it already, you need to fold the sides in to the middle line. Okay? And then you cut all the flaps along the dotted line. When you're done with filling it in, if you would like to glue it into your journal, you can glue it all the back here and then glue it into your journal so you don't lose it, or you can put it in a pocket. Okay, that's your choice. Starting with nags. Nags. Nag stands for all of the ways that you can see a function. Okay? Nag stands for all the various ways that you can represent a function. So if you're asked to give 3 representations, if you're asked to put a function in 3 representations, this is what you're looking for. Okay? These are the different ways to represent a function. Now, what does nag stand for? Well, if you open up your flap, you'll see it stands for numerical table, algebraic equations, graph, and sentence. Those are the 4 ways that you can represent an algebraic or a function. Get my paper here. Nag stands for numerical table. Okay, so if we had a numerical table, we could put numbers in there. So let's fill that table in. Let's say we had the equation y equals 3x minus 2. Y equals 3x minus 2. You can write that above your table, below your table, wherever you've got a little space. Okay? And when we're talking about making a table, we're talking about x's and y's. You can do this in the calculator, and you can do it by hand. Okay? When we talked back about domain and range, if we were given our domain, we were already given our x values. Okay? But if we're not given any, we get to make them up. We can pick any numbers we want. Okay? So if we have our numerical table, and how many spaces do we have on that one? Mine just isn't print.
4.
4. All right. So we have x and we have y. Alrighty. 1, 2, 3, 4. And it didn't give me any x values, did it? So I can pick any 4 values I want. But keep it simple. Don't pick big old numbers. Don't pick decimals if you don't have to. Pick some easy numbers. I always like to go with -1, 0, 1, 2, 3, 4, any other number you want. The reason why I do pick a negative number is to make sure you can see both sides of the graph, to make sure that even though on the positive side maybe it's sloping like this, what happens if on the negative side it flipped around? If you only did positive numbers, you wouldn't see that. So that's why you want to make sure you get some positive numbers and some negative numbers in there. But keep it easy. 1's easy to multiply by. So from here, once we've picked our x values, to find our y values, we're going to solve this equation 4 times. We're going to solve this equation 4 times. We're going to solve it once for -1. We're going to go back and solve it again for 0. We're going to go back and solve it again for 1. We're going to go back and solve it again for 2. Okay? So that little tab doesn't give you enough room to do that. So on the back of your foldable, there's some room. It says extra notes. Okay? So you can use there to show some work. So my first step is to plug in -1 for x. Okay, I'm going to erase my table here and make it a little smaller. I had -1, 0, 1, 2. X, y, like that. So I had y equals 3 times -1. So that's my x value. I just plugged it in.
Is this like the y section?
This is just finding a numerical table to represent a function. These are just the 4 ways to function. This is going way, 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 way back to the beginning. It's a very good place to start. Sorry, I watched The Sound of Music live. Can't help it. Alrighty, y equals 3 times -1 minus 2. I solve by multiplying 3 times -1, so I get y equals -3 minus 2. You can also read this as -3 and -2. If I read it as -3 and -2, then I'm going to have y equals -5. And if you weren't sure how I got that, punch it in your calculator. Okay? Negative 3 minus 2 will give you y equals negative 5. So then I can go over here and I can put it in there. Okay? Now, a shortcut, because that's a whole lot of work, isn't it, to do by hand? And you get a graphing calculator on every test, including your end of course. Everything gives you a graphing calculator. So a shortcut to this would be to take this equation and put it into the graph screen. Okay? Now on your graph screen it doesn't give you y equals, what does it give you? F of x. So you would type it in and it's going to graph a line for you. Then if you press the button Control T, that's going to give you your table because table starts with T. Press Control Table, it will give you this table all filled in for you. So all you have to do is write them down. Okay? It'll give you every number. It'll give you all the decimals, all the fractions, all the negatives, all the positives. Alright? That's a very, very, very useful tool. However, in your graphing calculator in our Inspires, make sure you're not using the graph where it says B. It says Scratch Pad A Calculate B Graph. Don't use the Scratch Pad. Make sure you go down to the bottom and use the Picture app at the bottom. They're different. They both graph and they look the same, but they don't have the same functionality. The Scratch Pad doesn't do all the cool tricks that the other one does. Okay? So that's your N. Your next letter is A, Algebraic Equations. Alright? Can I erase this one? Did you got that written down? Control T and everything? Alright, the next tab says A, Algebraic Equation, and then you have y equals mx plus b, and then you have ax plus by equals c, right? This is your slope-intercept form. Slope-intercept form. Why is it called slope-intercept form?
You can graph it?
Well, yeah, you can graph it. That's one reason why. Yeah. But it's also called slope-intercept because that's what's in the problem. I have the slope and I have the y-intercept. Slope-intercept formula. That's where the name came from. It tells you what you got. This is what the calculator understands. But what if you've got this right here? How do you go from here to here? Well, that's what we're doing tomorrow. Okay? It's talking about how do you go from here to here. Okay? Next, you can graph it. Okay? That's your G. So let's go back to that original one I had. What I have, y equals, what I have on the table?
3x minus 2.
3x minus 2. So if we have this one, and we wanted to graph it on that graph that's provided for you, I'm going to start with my B. B stands for beginning. I begin with my B, which is my y-intercept. My y-intercept is negative 2. Okay, negative 2 is right here on the y-axis, always on the y-axis. Then my movement, my slope is 3. Well, it's not a fraction. I need a fraction for slope. I need a rise
3 over 1.
over run. So it's going to be, you're right, 3 over 1. Okay? So that means from this dot, I'm going to go up 3, right 1. If it had been negative, I would have gone down 3 and right 1. But because it's positive, I'm going to go up 1, 2, 3, right 1. Now I have 2 dots. You need 3 to make a line to make sure you do it straight. So from here, do it again. 1, 2, 3, over 1. There's how you graph a line. Okay. Because we started late, just so you're aware, I am going to stay late as well. If you're unable to and you have to leave at 4:45, that's fine. Just do so quietly. Okay? Alrighty, sentence. What if it's in a sentence? Okay. You had a lot of those today up on the wall. grab example problem over here. There we go. During a drought, researchers measure the water levels at Lake Louisville and determine it is 59 feet deep. The next day, a steady rainstorm causes the water level to rise by 1/4 foot per hour all day. Write an equation for the water level W as a function of the number of hours that pass. So that sentence right there. Write the equation. Write the equation, so that's the direction. That tells you what you're going to do, right? This is the sentence tab, yeah. Write the equation for the water level, comma W. Now let me finish writing and then I'll digest it or take it apart here. As a function of the number of hours that have passed H. Okay? Pass this around to you. Pass that around. That's number 1 from today's homework. It's number 1 on Thursday's gallery walk. That's where this is coming from. Now, how you take this problem apart. Okay? Whenever you see a sentence like this, for the water level W, write the equation. That's what it told you to do. You know you're going to write an equation. From that information, because it says equation, you know you need an equal sign. The equation told you you needed an equal sign. For the water level W, if you see this word for, it's being written for something, that's telling you that's the Y value. Okay? The word for what? Write an equation for what? Whatever follows that for word, that's your Y value. So this right here tells me that I'm going to do W equals something. Okay? Write the equation for the water level. That means I'm going to write W equals. That's where you start. That's how you begin. Okay? I know that's the hardest step in a math word problem is how do you start. This is right here how you start. Then it says as a function of the number of hours that have passed. Okay? So you've got the number of hours that have passed, right? Well, what letter does it say to use?
H.
H. So that's going to be my X value. And we already know that our line is always in what format? Y equals mx plus b, right? So let's go with that. W is my Y. So I'm going to have some number for m. And then I'm going to have H. And then I'm going to do plus some other number. Now, this sentence doesn't give us the information. We have to get that from the rest of the problem. But that's the format you would use. The word for tells you your Y value. The other value, or the other letter, is your X variable. Does that make sense?
So isn't that Y?
So this would be our Y equals, whatever this number is, would be our M. H would be our X plus whatever number was B. We'd have to go back to the problem to get the information. Okay? But I will tell you it's 1/4 and 59. Because it was 59 feet of water to start, and it rose 1/4 of a foot per hour. Okay? All right, moving to the next one, function machine. I'm going to move through the first part fairly quickly so we can get to the actual application part. Domain is what? What is domain? The X.
Oh, X.
Domain is X, domain is X, domain is X. By the way, domain is X. Okay? Domain is always X. It's also your input values. You might see that word. It's what you put into the information. It's what you put into the problem. On this one, hours is the information I put into the problem. Hours is what I knew. I didn't know the water level. Okay? Domain is your value that you know. Okay? Domain is your known value. Range is going to be your Y values. It's your output. Okay? Now, your vertical line test only works on a graph, and it tells you whether or not something's a function. Okay? You can graph an equation and get a line, but every line that you graph is not necessarily a function. Okay? To be a function, it has to have a proportion going on. Okay? It has to increase at a constant rate. That's your slope. If the line doesn't increase at a constant rate, then it's not a function. So, for example, if I have this graph, say I have that graph right there, and I do my vertical line test. I'm going to use green. My vertical line test, I just draw a vertical line anywhere on the graph. How many times does it cross that black line? Once. If it crosses the graph one time, then it's a function. Okay? What about if I had, draw my grid, my coordinate plane. What if I had this graph? It's a nice curvy line, isn't it? I do my vertical line test. How many points does it cross? 2. So this is not a function. Okay? What about this one? What about that one? Do you think that one's a function?
Yes, no.
Yes and no's. We hear both of them. Let's draw our line. How many points is it crossing?
1.
It's just 1. That is a function. Yeah. It's a quadratic function, but it is a function. It's not a linear function. Because it doesn't make a straight line, does it? It makes a curve. It's a different kind of function, but it is still a function. Alright? So let's do some practice problems. It says, ooh, mine's blank. Can I borrow yours? Mine is a nice blank square. It says to find f of x equals, let's do black here. F of x equals negative 2x plus 1, and g of x equals 3x minus 4. And it's asking us to find f of x when x equals negative 2, when x equals negative 9, and then a fun one, f of 2 minus g of 1. That one's kind of crazy, right? Alrighty. Which one you want me to do first? The hard one or the easy one?
Hard one.
Let's do one of the easy ones first. Okay. Find x when f of x equals negative 9. What this is telling me, all I'm going to do is plug in negative 9 into the equation for x. And it's asking me to find f of x. Okay? Or find x, really. So all I'm going to do is go right back up here. F of x equals negative 2 x plus 1. So I'm going to replace my x with negative 9. That's all it's asking me to do. Okay? Does that make sense? All it's asking me to do. Then you solve it. F of x is going to equal negative 2 times negative 9. You get positive, because negative times a negative equals a positive. 18 plus 1. 18 plus 1 is 19. That's all it's asking you to do. It's the same thing as saying what is y equal, because f of x is the same thing as y. Y is f of x. F of x is y. Y is f of x. F of x is y. They're the same thing. Okay? Oh! Crummy, hang on. Erase that. Sorry, guys, I skipped lunch. I'm not thinking straight. Erase that. Remember what I just said? F of x is y? This says f of x equals negative 9, doesn't it? So does that mean x equals negative 9? Or y equals negative 9? F of x is the same thing as y, right?
So y equals negative 9.
Very good. Y equals negative 9. I plugged it in the wrong place. My bad. I need more caffeine.
How does it, what?
F of x equals negative 9, so that's the same thing as saying y equals negative 9. Because f of x does equal y. They're the same thing.
Where did you get negative 9?
Written on the paper. negative 9 because it's written on the paper. Okay? So I'm going to go back and plug it in. Turning box. Okay? I'm going to go back to this problem right here. F of x is negative 9 equals negative 2x plus 1. Now, the key there, so you didn't make that mistake, is look what it says. It says to find x, right? So that right there told you that negative 9 isn't x, because it's asking you to find x. It wouldn't give you the answer. So negative 9, so now we're going to solve this. Subtract 1 from both sides. Cancels out. Negative 9, negative 1 gives me negative 10 equals negative 2x. I'm going to divide by negative 2 on both sides. This one cancels. Negative 10 divided by negative 2 equals a positive 5 equals x. So that's the second example. Now look at the first example. It said find f of x when x equals negative 2. Do you see the difference in the writing on those? One is asking you to find x, and one of them is asking you to find y. Let me write it up here. It says find f of x when x equals negative 2, or it says find x when f of x equals negative 9. Okay? This one's asking you to find x. This one's asking you to find f of x. Is it saying the same thing? Those don't say the same thing, do they? No. I'm sorry. So this one's asking you to find, this is saying exactly the same thing as find y when x equals negative 2. This is the same thing as saying find x when y equals negative 9.
If you leave again, you're done.
Okay? Those mean the same thing. They're just fancy ways of saying stuff. Alrighty. The bottom one says, alrighty, so we're resuming there. Sorry for the timeout there. Had to deal with something else. Back to our regularly scheduled math problem. Can I borrow your paper again? I promise to give it back this time. It says to find f of 2 minus g of 1. Okay? That's what it's asking you to find. Okay? This is actually a 3-step problem. You first have to solve f, then you have to solve g, then you have to put it together and subtract what answer you got for f minus whatever answer you got for g. That's a 3-step problem. Okay? That's the nitty-gritty of it. So this is asking you if f of x is f of 2 equals negative 2x plus 1. This 2 goes right here. Because they wrote it in the parentheses, that's the x value. So instead of writing f of x, they replaced the x with a 2. Right? So that means x equals 2, not y equals 2. If they had written f of x equals 2, if they had written it like that, then that would have been y equals 2. But because they put the 2 in the parentheses, that's the value of x. Okay? So we're just going to replace this x with 2. So we get negative 2 times 2 plus 1. Negative 2 times positive 2 gives me a negative 4 plus 1. Negative 4 plus 1 is negative 3. Okay? So we now got that answer. Now we go back and we're going to solve it again for g. So we have g is 1 equals 3x minus 4. And I got this from way back up here at the beginning at the top of the page. I'm going to plug in the 1 for x. So g of x is going to equal 3 times 1 minus 4. 3 times 1 is 3 minus 4. 3 minus 4 is negative 1. Okay? So now I have my G value. So I'm going to take this number, take this number, I'm going to plug them back in into the original problem. So really what this is asking me is, what is negative 3 minus negative 1? It's a big old long fancy way to give me a simple subtraction problem. Okay? So we go back in. F of 2 is negative 3. G of 1 is negative 1. And then I have a minus sign in here, so I'm going to put parentheses here. You know what? I'm going to put that in different colors so we can see it. This was negative 3. This is negative 1 minus, put my parentheses. When I've got my double negative, it becomes a positive, you're right. So I'm going to change that to plus 1. Negative 3 plus 1 is going to give me a negative 2. So my final answer would be negative 2. Questions on that one? Real long, nasty problem, right? But not nearly as complicated as thought might be. All right, let's look at the graphing section of your Foldable. This one's all filled in for you. These are all steps and points to use. Okay? Mine's a little messed up. I reprinted it before I gave it to you guys because my first one got all messed up. It didn't print right. When you're graphing, the first thing it says is to pick smart when graphing. Which form is your equation in? So if you're already given y equals mx plus b, then you should graph using the y-intercept and the slope. You start with b, and then you use your slope to move. Okay? If you're given ax plus by equals c, given that big old long problem, then you should graph using your x and y intercepts, meaning plug in 0 for x and solve, and get a point. Plug in 0 for y and solve, get another point. Once you have 2 points, you can connect the dots and make a line. Okay? Don't make things harder on yourself. Keep it simple, silly, right? Just keep it kissed. Keep it simple, silly. Next, you have slope-intercept form and standard form. It tells you how to do it. Okay, so I told you to graph it. Then here in the middle, it shows you how to do it. 1, 2, 3. 1, 2, 3. So if you can't remember, there it is. If you've got slope-intercept form, it tells you 1, 2, 3 what to do. Standard form, 1, 2, 3 what to do. The last one is your third option for graphing. You can use a numerical table, which is what we did way back here in the first tab. We picked 3 numbers for x, we solved, and we got our y's. That's your other option. Okay? So if you forget how to do that, there's the steps right there. We did it under N for nags. There's the steps. Does that make sense? Okay. Bottom, let's talk slope. And what does this funky little triangle mean? Slope equals what letter? Slope is M. Okay? M means, slope is M, which is your rise over run. Your rise over your run. Okay? Which is simply, when you have 2 points, the change in y over the change in x. Change in y over change in x. So for those of you filling out TRFs and you have like this much room to write for our AVID class, this is shorthand. That's all this is. Okay, you're always told to use abbreviations and shorthand in your notes where you can. That's what this is. It stands for change in y over change in x. So that triangle stands for change in. Does that make sense? How do you find changes in math? Do you add, do you subtract, do you multiply or divide? You subtract. So that's why it's y2 minus y1 over x, over x2 minus x1. Okay? So that's your slope. In case you've forgotten, your next tab tells you about parallel and perpendicular slopes. Okay, parallel slopes are the same. Perpendicular slopes are the negative reciprocal. Okay? Those are some big words, aren't they? Okay? Negative reciprocal. It means if it was positive, make it negative. If it was negative, make the other one positive. Reciprocal is back when you were learning to divide fractions. You remember you had to flip the fraction? That's the reciprocal, flipping the fraction. That's what reciprocal means. So if I had 3/4, what would the reciprocal be? 4/3. But it's not just that. This one's positive, so this one's going to be negative. So it's the opposite reciprocal. So if it was positive, I make it negative. That's how you do perpendicular lines. So this slope, so let's go with, if I have this slope, right? Say that's a slope of 1 about. Actually, let's make it easier. Let's say that's the slope 1/2. So its perpendicular one would be that way. Because remember, perpendicular makes a right angle. Well, that's a negative slope. I can tell by looking at it. It goes down the slope mountain, right? So that's a negative slope. So it's going to be negative, and it's perpendicular, so it's actually 2/1 now. Okay? So that's how you do that. Make that look like a negative. There we go. Ooh, I'm getting marker on my arm. Last box is the graphing inequalities. This is another little cheat sheet for you. It tells you solid line is your greater than, less than, equal to symbols. Your dotted line is just your greater than, less than. Okay, you might want to make a note that that's the same thing as a closed dot and an open dot if you're doing it on a number line. Okay? And then my thing is blank again. It's missing the text. Sorry, I keep stealing yours. There's your steps. Step 1, graph the equation. Step 2 is the line dotted. And step 3, shade it using a test point. Okay? So when we're on this graph right here, we're going to do an example problem. Alright. Say we have the inequality y is greater than or equal to, actually I don't want to do equal to, let's just do y is greater than negative 4x, I don't know, plus, so let's do minus, here we go. Let's go negative 4x minus 8. How's that work for you? Why not? Your graph should go all the way to 8 on your paper. So I'm going to begin with my y-intercept, just like I do equations. I'm going to put a dot right there at negative 8. That's my y-intercept. Then I'm going to move with my negative 4. So I know my slope, because it's negative, is going to go in this direction. I also know by this symbol, because it doesn't have the equal sign, it's actually going to be a dashed line. I do that by just drawing a solid line and taking an eraser to it. Okay? So it's 4, so that means it's 4/1. I'm going to go down 4, right 1. Down 4, right 1. Down 4, right 1. Sorry, that was my warning that it's time to go. Let me finish this problem, then we'll stop. Because my y-intercept is already at the edge of the graph, I can't exactly go down, can I? So I'm going to go the opposite. Instead of going down and right, I'm going to go up and left. Okay? It'll give me the same line. I can go up and left, and I'll still get to the line. So I'm going to go up 4/1. I'm going to go up 4/1. Now I have 3 lines, or 3 dots, so I'm going to connect them. I'm going to put arrows on the ends. And because it's an inequality, I have to shade. Now, don't think about above and below the line, because with this line, I don't really see an above and below. I see a left and a right. Okay, so it gets kind of confusing here. Look at where your y-intercept is. Think about shading above and below just that dot. Okay? So this says y is greater than. So that means the shading represents your y value. So it's telling me the shading should be numbers greater than my y-intercept, because it's chomping at my y. Y is greater. Okay? So I need to shade everything greater than this dot. Okay? Where are the numbers that are greater than that dot? Above it or below it? Above it. So I'm going to shade all of the y-axis above it. But I'm also going to shade the rest of the graph. that make sense? So if you just look at the dot, it helps you decide, is that above or below? All right? And you can think of your y-axis like a thermometer. The hotter numbers are at the top. The lower numbers or the colder numbers are at the bottom. Okay?